Hi, this is Janardhan. I'm going to explain my MTech Bioinformatics thesis project. For my project, I'm going to test a novel data analytic algorithm on biological data. Algorithm I designed is counter school search, which can be used for discrimination and regression of biological data. It is easier to implement and faster than many machine learning algorithms. I'm going to start with an introduction to artificial intelligence. This is Talos, a Greek mythological being, a giant automation made of bronze to protect Europa. Artificial intelligence can simply be defined as intelligence demonstrated by machines. Several forms of artificial intelligence: machine learning, natural language processing, robotics, vision and speech demonstrated by machines. There is a concept popularized in Hollywood movies that machines will dominate mankind with artificial intelligence. There are three classes of algorithms by which artificial intelligence can be implemented: machine learning, genetic algorithms, and swarm intelligence. We can do the explicit programming also if we know the task, what to do, like what machines are supposed to do. If we know the task, we can do the explicit programming also. This classification of algorithms by which artificial intelligence can be implemented is my personal opinion. Most important algorithms class by which artificial intelligence is implemented is machine learning. Machine learning is usually confused with deep learning. We see what is the difference between machine learning and deep learning. Deep learning is a part of machine learning, which in turn is a part of artificial intelligence. Artificial intelligence algorithm machine learning is by which mathematical models can be built which improve automatically through given data called the training data. Like in machine learning, machines learn from experience. Arthur Samuel, a pioneer of machine learning in 1959, described machine learning as follows: a field of study that gives computers the ability to learn without being explicitly programmed. Types of machine learning: supervised learning, unsupervised learning, reinforcement learning, feature learning. Supervised learning, we deal with data sets with both inputs and desired outputs. Models are built with these kinds of data sets. In supervised learning, we have classification problems and regression problems. In classification problems, we build models which will be able to distinguish between categories of data points, like artificial neural networks built using perceptrons. In regression problems, we deal with relationships between variables, like how an independent variable gives rise to a dependent variable. Examples of regression models: linear regression, non-linear regression. In unsupervised learning, we have models building without any given output, like we build clusters, self-organizing maps, etc. This is a biological neuron. We have an example of machine learning algorithm inspired by biological neuron. A perceptron is a model of biological neuron. A perceptron is a form of supervised learning. It will be able to distinguish between classes. Classification is done by producing a linear predictor function which is a straight line. It is a weighted sum of input features. The weights are adjusted using back propagation. Like in back propagation is implemented by different algorithms such as gradient descent. This is a single layer perceptron. You can see there are two input features along with a bias input feature. Those are weighted with W0, W1, W2. This weighted sum is again given to activation function to produce the desired output. You can see at the output layer we have the actual output as activation function of the weighted sum of inputs. This classification line is a linear boundary which divides the feature plane into two parts. This classification line is produced by the perceptron using the training data. This is a good example, simple example. You can see based on the input features, length of the vehicle and weight of the vehicle, you can see perceptron has built a linear classification line which can separate vehicles, lorries and vans based on the input features, length and weight of the vehicle. Another example, based on features, domestication and size of the animal, a perceptron has built a classification line which can be used to separate a given unknown animal, whether it is a cat or a dog. You can see as the number of examples is increasing, the classification line in iterations become better and better, and finally it will be able to classify correctly the given example to what class it belongs to. These are the steps in weight adjustment. This is also called learning. You can see after the actual output is produced, the weights are adjusted using delta rule. In the second step, you can see it below, where R is the learning rate, dj is the desired output, and yj is the actual output, and xj is the example. Perceptron iterations are terminated once a lower cutoff value of the error function is achieved, or the number of iterations the user has defined is finished. This is the error function uh, which we can use for back propagation. I prefer squaring the difference between the desired output and the actual output. It will be easier in implementing the computer program. This is an example how a perceptron can be used for classifying data in case of biological data sets. In this data set, we have two kinds of data points, benign cancer and malignant cancer. This is breast cancer data set. One feature is radius mean of the breast infected, and one other feature is the text mean of the breast infected. You can see the perceptron has failed to classify correctly some of the data points, the red crosses, which are actually the malignant forms of cancer. So the remedy for this kind of errors is deep learning. Deep learning is nothing but implementing multiple layers of perceptrons. Like you can see here, the output of one layer of perceptrons is given to the other layer. So you can see in this example there are two perceptrons, and the weighted sum is calculated at once, which is given to the activation function. This is multi-layer perceptron. You can see a hidden layer is there between input layer and the output layer. This hidden layer consists of additional perceptrons which can be used for deep learning. Deep learning produces various classification lines other than a straight line. Deep learning can also be used for feature extraction. This is a straight line which is produced by single perceptron. While when we use deep learning, different lines can be produced as shown, non-linear lines. Disadvantages of some deep learning, like if it is very difficult to implement, like I when I try to implement it in a basic C program, like it takes some 200 lines. It is computationally expensive also. It takes more number of iterations. Second class of artificial intelligence algorithms, genetic algorithms, which are algorithms inspired by Darwinian evolution. John Holland introduced genetic algorithms in 1960 based on the concept of Darwinian theory of evolution. Um, like in evolution, the system achieves the satisfactory solutions by making mistakes. There are four genetic operators or evolutionary operators used in this algorithm: reproduction, mutation, crossover, selection, etc. These are the general steps used in genetic algorithm: initialization, selection, mutations and crossover, termination. Initially, a population randomly is generated. Out of that population, a fittest organisms are selected, and with the organisms, in that organisms, mutations and crossover uh, take place, and new population is produced, new generation is produced, and these steps: selection, mutations and crossover, and reproduction, these are repeated till a satisfied solution is obtained. This is an evolved antenna designed using evolutionary algorithms. It is produced in 2006 by NASA. It was used in ST-5 spacecraft. This complicated shape of antenna was able to produce a very difficult radiation pattern. And the third class of artificial intelligence algorithm, my favorite, is swarm intelligence. It is an intelligence of collection of organisms or elements with no intelligence, but as a whole they produce some kind of intelligence. These are starlings, a small birds, a flock of starlings. They produce very complicated shapes. Like it is very difficult to understand how they produce these kind of shapes: height, cloud, etc. Each starling communicates with at least 6-7 birds, but as a flock they move in hundreds, and they produce very complicated shapes. This is a swarm of robots with small memory, and they follow few basic rules, and with proper communication with each other, with the neighboring small robots, they will be able to produce complicated shapes like this, like starfish, screwdriver, etc. So this is about swarm intelligence. Collective behavior of a group of organisms like school of fish is different from the individual behavior. A school of fish, for example, will be able to perform complicated tasks like pattern formation, which is otherwise impossible by individual fish. This is seen in ant colonies, bee swarm, flocks, packs, etc. With this collective behavior, they will be able to find food easily, escape predators. And swarm intelligence, like the individuals or organisms, they particularly don't have um, intelligence, considerable intelligence, but they will be able to exhibit some kind of intelligence capable of making decisions with proper communication with each other, like neurons in the central nervous system. This is a school of fish. You can see each fish is not able to, each fish doesn't know what it's doing, but as a school of fish, they are able to produce a ring structure. You can see they are able to escape predators. This is possible with each fish following few basic rules like swimming close to neighboring fish and maintaining distance from the fish. And if one fish initially tries to have a radius of curvature around this seaweed, this entire ring structure can be formed with that school of fish. So this is the algorithm I have designed for my MTech Bioinformatics thesis project. The algorithm is counterfield school search discriminator.